So they have all these signs for all these values, and it's a very sophisticated civilization. Why did not they standardize it? And turns out they did standardize it, and it became Brahmi. So in these squares, if you look at the values, in each square the bottom left is Brahmi, the bottom right is Indus script. So you can see how similar they are. The inscriptions, they are of a religious nature, and they are essentially mostly about Rudra and Vedic gods, and a couple of Puranic incidents. So based on that, based on the iconography and so on, it's pretty apparent that Indus people were also Vedic people. In my paper, there's a list of mixed Indus Brahmi inscriptions where some letters are Brahmi, some letters are Indus, and so on. Okay, and you see over time the Indus characters get fewer and fewer, and the Brahmi characters get more and more. The best example is that is in Kiladi in Tamil Nadu. The earliest stages have only Indus inscriptions, then you have a mix of both, and then on top you have only Brahmi. Thank you, Sangam Talks, and for this opportunity. Very happy to be here. Thank you for all Mr. Dhawan and all the wonderful people here. So let me start with the history of how I came to face this problem, or to solve this problem, and how, just kind of to give you a sense of the journey. So most of us have seen here and there on some web page, some newspaper, some article about the decipherment of the Indus script done by very famous people such as Askoparpala or Mahadevan, and generally it would be 2 or 3 characters, and there would be about 10 or 12 inscriptions, short inscriptions, length of 2 or 3, being claimed to have deciphered. I have also seen it, and I did not really think much about it, in the sense it was not a topic I was involved in at that time. During COVID, everything was shut down. There was a lockdown. You could not go out, no movie, no restaurant, nothing. And I was looking for something to occupy my mind with, and I ran into this problem. There was many different newer claims. So the old claims, most of you may have heard about S.R. Rao, some work by Hunter, Askoparpala, Mahadevan, and so on. But there's some new people had also done work, and I started looking at their work. And one of them was a person named Sue Sullivan, who had claimed to have deciphered a whole number of inscriptions and long inscriptions. So that increased my curiosity, because it is one thing to just put 2 letters, 2 signs, and say I can read it as this if I claim these are the sounds. It's another thing to assign sound values and try to read larger. And there's a whole group of them, who claim it as it was in Tamil or some Prakrit or various different languages. And the interesting thing was none of them agreed with each other. So they were all completely different decipherments. So I started looking into this problem, because it looked like it will keep me busy for a few months. And COVID, you don't know how long the lockdown is going to be. It ended up being a few months. So I said, okay, let's start. And I tried different things, and I tried many, many different things until I figured out it can be approached as a cryptogram. So if you guys are very young, you probably never heard of cryptograms, but in newspapers they used to be a little puzzle, and you can solve it by knowing the adjacencies of the symbols. So a cryptogram is essentially a message written in a known language but unknown script. And you can see that if there's a short words, it could be the or and you can kind of guess, and you can see if that letter works somewhere else and solve it. So this is a known way to solve ciphers, and people have been solving this for hundreds of years. Okay, in the last 100 years, over 100 million cryptograms have probably been created by newspapers and solved by people. So it's not a new technology or a new mathematics or anything like that. It is well known, well understood, and there have been many papers written on knowing if a cryptogram has a unique solution. So, we will get into that a little bit. So, once I figured out it can be solved this way and I started getting results, I started communicating it on Twitter, and eventually I was able to get the decipherment, but the problem is the decipherment is one of many, and it needed something more rigorous, something that is close to proof. So, although the talk is titled Advances in decipherment, the title of the thing is Math of the Indus Script Decipherment, because I am just reusing this slide. It looks I kind of like the way it looks. This was a slide made for IIT Hyderabad and IISc Bengaluru. So, when you talk about a decipherment, when you talk about a script, most people just are familiar with the script that they use, maybe one or two, but the scripts are a mathematical abstraction, and it is good to understand what they are before we have the foundation to understand whether the decipherment works or not. So, to understand the script, you have to understand what language is, and to understand language, you have to understand how the mind works. So, the human mind is inherently wired for language. So, you could put two children in a spot and isolate it from all other language, they will develop their own language. Okay, your brain is inherently wired. You put a child in any culture, it will pick up that language. Okay, it acquires that language. So, you acquire the language from people around you, and you do that because your brain is a symbol processing engine, and your brain associates actions and objects and concepts with strings of sounds. Okay. So, when you say that when you want to express an idea or when you want to discuss a concept, you pick up from other people that they are talking about this particular object or action, and whenever they talk about it, there is this string of words. So, you may have noticed children, most of the things children talk about are declarations. They will point and say car, cat, and that is because they have done something amazing at their level, which is they have stored that string of sounds, they have looked at the object, they have found the association, and they have reproduced that string, that string of sounds, and that is actually a pretty big accomplishment for someone that's 2 years old. And adults reinforce it and say, yes, that is a car, very good. So, the kid knows, yes, they have successfully. When we talk about objects that way, however, you're not just like a child that just says cat, dog, and you need to, that is, you need more work to express concepts, you need more information. So, you need to add things around that object. So, you would say with cats, of cats, and so on. If you're talking about actions, you also have to talk about whether it happened in the past, it's going to happen in the future, and so you attach things around those strings of sounds. These may be, you may call them affixes, prepositions, and so on. Now, you may think that is it possible that why should I use two words, with cat, can't I just use a shorter string of letters, can't I just say calf or kaj or something like this? Will the other person understand it? Yes, as long as you agree, the other person will understand. The problem is the human mind, the language is optimized for cognitive load. Cognitive load is the number of concepts you can hold in your brain at any time, and if it is not optimized for symbol storage, so it is because it's a lot easier for the mind to essentially minimize the number of symbols and create an explosion of words by simply multiplying those sets. So, for example, in Ashtadhyayi of Panini, 2000 words, 4000 rules can create billions of words. So that is very powerful. Your brain retains a core set, and very quickly it can express a lot of concepts that the other person can parse and also understand. So the thing about the advantage of that is that if you having them in different sets is that when one member of the set grows, you don't have to create associations for everything. So with cat you had calf, catch, whatever. With dog you don't have to add a whole bunch of things because your set of affixes are standard. You can you can leverage your understanding. So let us do a little bit of experiment. So this is a 8-letter word, and first for our TOGE, and I want you to guess what this word is. Don't say it, guess it. Yes, madam, what do you think is a word? Together. Okay. Anyone else? Together. Did anyone think of any word other than together? Nobody. So almost everyone, in fact everyone guessed together, people who guessed. Other people are shy, but I'm sure that's what they would have guessed because there is only one word that matches this pattern. What does this tell you? It tells you that 4 letters are redundant. They are redundant, they are not needed. So this property in language is called redundancy. Okay, and redundancy is what enables compression. So if you have you may have compressed text in the old days. Nowadays it's all automatic, but in the old days you would do gzip or something and you would compress text and it would all compress to about 30-40% of the original size. And it's possible because of essentially there is structural symbols that don't actually carry information. So redundancy is something that exists in all languages. It defines the redundancy of a language, defines how much you can compress it, and for most natural languages it's almost the same. It's about 70%. Some of them are slightly more, some of them are slightly less due to various historical reasons, but in general roughly that's about what it is. And we can experimentally figure it out. See, here we experimentally figured how much it is, but imagine I do it for many words. I can average that and I can actually calculate what is the redundancy of a given language. So to continue with the structure of languages, this sounds like a linguistics class. The reason you need to know this is when people challenge you or me and say, well, why isn't this Dravidian, why isn't this Sumerian? This is essentially the reason. So in most languages of the world, 80% of the languages are what are called agglutinative languages. So in agglutinative languages, the affixes are regular. Regular meaning for each concept there is one affix. For plural there is an affix, for gender there is an affix, for number there is an affix, for possessive there is an affix, and this is about more than 80% of the languages. And some languages like Indo-European languages are what's called fusional. Here what happens is all those affixes are fused. So for those who know Sanskrit, Ramaha, Rama, Ramaha, it's different. Ramat, Ramabhyam, Ramabiha, they are different. You can't see any common elements in those things. So it kind of takes all of the concepts and it gives an indirect association of some other affix.
What's an affix?
Affix is like if you say Rama and Ramasya, the Asya is the affix. So it changes the meaning slightly. So from Rama you become off Rama. So in English, for example, you use prepositions to get that same effect. There's one more which is actually English or some of East Asian languages where the meaning is determined by word order. So now let's come to script. So in terms of scripts, there are different scripts, and this is also important to know because when someone claims it's this kind of script, it's important to know whether it actually is that kind of script based on the glyphs. The oldest or some of the most ancient scripts are what are called logographic. Logographic just means it's just a picture of a thing. and it represents either that thing or something that sounds like it. So the pre-Sumerian scripts are all logographic. So when they were trading some goods, they would put a picture of that good on the jar, and that even though it got abstracted, it started representing that particular object. So that's all logographic means. But eventually what happens is most scripts develop into something called logosyllabic. Logosyllabic means that you would also some of the objects would represent actual objects, others would represent the sound of that object, like the starting sound of that particular object. So for example, if I have dog, it could stand for dog or it could stand for doe, okay, and that kind of people starts they are able to use it and read it and so on. So Chinese and Egyptian are kind of the classic examples for logosyllabic. And logosyllabic typically have large sign inventories. Why? Because there are a large number of objects. So Chinese, for example, has some 40,000. I mean, they actually have a lot more because the old texts have symbols that most people don't even know. So eventually what happens is the logosyllabic, they will kind of standardize it, and I mean not always, but sometimes there's the opportunity to standardize it and have a smaller set of symbols that can encode more speech, and that's called syllabic. There are many syllabic scripts, like hiragana today is in use in Japanese. They have essentially a consonant vowel combination, and different symbols stand for that. You can just attach it and read it. For some languages you don't need to indicate the vowel, so you may have noticed sometimes when you write in a text message, if you don't put the vowels, you can still read it. That is because if there is no distinction between long and short vowels, you can leave it out, and such are called abjads. So in alphabets, is like Latin or in English, there is a separate symbol for a vowel and consonant, and that is kind of a little more compact form of, like, the number of symbols you need is reduced because of that. Abugida is a kind of it has one foot in alphabetic and one foot in syllabic because it has a default a vowel, and if you want to change it, you attach something to it or you override it with another vowel symbol. Now this essentially language can be modeled mathematically as having this particular pathways where it travels from for each letter from the beginning of the word there are certain probabilities, and if you just draw them all, you get something like this. But for real languages, it's just so big that you can't really put it on a slide, or you would need special software to read it. But you can create different versions of that based on the script you want to represent. So this you would use for alphabet, this you would use for abugida, for example. Now those patterns are unique due to something called phonotactics. Phonotactics is constraints in languages. So languages have constraints on what sound can follow what sound, and these are called phonotactics. And because of phonotactics, these graphs are unique, and the patterns of what letter or what sound can be next to another sound are kind of unique, which means you cannot actually fit you cannot read one script in one language as another script. So you cannot take a Japanese text, assign English letters to it and try to read it as English. You just won't find any words. So this is an example of it. For InterScript, the top line is InterScript, the middle line is the actual values of my decipherment, and the bottom line in orange is random values that I have assigned. And we try to read it, you can't read it because those patterns don't exist in the language the script was originally written in. So whenever you assign random values, it's usually unreadable. Now for short inscriptions, you may find something readable because it's just a matter of probability, but over the whole corpus you won't be able to read a lot of things. Now what happens if you assign it instead of random to an actual language? You find some more words, but many words will be missing. And if you assign the same language but different values, you will get words, but it just won't be meaningful. Okay, so you need the exact values assigned to the exact symbols to be able to read meaningfully. Make sense? So I understand this is a little bit abstract, but when you view the thing again, or on the video, I think you'll appreciate that, appreciate this information. Okay. So now let us see how we will decipher the interscript, how anyone will decipher the interscript, or any script for that matter. You can decipher pretty much all non-logographic scripts in this manner. So you saw that Markov process, the graph thing where all these arrows are connecting letters. If you take one path of it, if you take the path for one word and lay it out like this, it will kind of look like this. And if you join the letters that are the same with, like, if you connect them, you get what is called a residue class in mathematics. Residue class means that if you change the symbols of the so here I have written papaya. If you change that papaya to something else, like if you change the P to K and the A to I, it will be kiki, or you change it to whatever else, it does not matter. The pattern looks the same. So the letters are just dummy variables. What matters is the interconnection, the adjacencies. That is what is used to decipher scripts. Okay. So these particular examples, papaya and millennium, are unique in the sense that if I try to find words that match this residue class, I get only one match in the dictionary. So if I find a pattern like this in any text, regardless of what the symbols look like, and I search the dictionary for this pattern, I will determine, for the first one I will determine 3 letters, I will get P, A and Y, because there is only one word that fits that. Think about it. Okay. There is no other word has this pattern. That means only this, these letters can be the value of those symbols. I hope you understand this. Okay. Same thing for millennium, and there are many words like this which give you a starting set of values. Now what if none of these exist? You just have to use more words. So on the right I have 4 words made of ASP, and I just draw the lines, and that connecting the lines, that is called a residue set. You essentially get the words that match a particular pattern and you do intersection. Okay. So you do intersection of the words. I will show you what that means. So first of all, let us see how we get those values. So for papaya, above papaya I have written that in unknown script. Actually it is Greek, so that you kind of have an idea of what it is. And above that you see the pattern, that is called a regular expression, that can be used to extract all matching words in the dictionary. So the dot in parenthesis means capture this, remember this, whatever is on this position, call it 1. The second one is remember this also, call it 2, and the rest of it is just hey. Backslash 1 means hey, here I am also using the same, I am using the first thing you captured. Backslash 2 means I am using the second thing you captured. Dot means I do not care what it is, and when you extract it you get this. Okay. So you got the values. So once you have a set of values, you just repeat the process. So here I have another symbol that I do not know what its value is, but I have the value A, P and S. I can say I can find 3 inscriptions or 3 words which have this symbol and only other symbols whose value I know, and I can just do the same thing. I can search, I get these words, and I can see for those positions what is the intersection in this set, and in this example we get only T. So now I have deciphered this extra letter as T. Now for the next one I can use this letter also to find new letters. That is basically it. That's the whole way to decipher any script using the cryptogram method. As I said, this is a very ancient method, hundreds of years old. It has been solved more than 100 million times. It is not new. None of this is my invention. Okay, so far whatever we have talked about. I need you to understand this, because a lot of people will say, oh, cryptogram, what is it? He is using it as they try to rubbish it, but it is not a new art I have invented. It is proven hundreds of millions of times. Okay. Now let us see if we can assign this technology to the InterScript. So you saw that we use the English for our example. Does it work for non-English? That's the question. Now this is about a little bit about InterScript. So you guys are all in Delhi. If you haven't seen the National Museum Harappa exhibit, please go look at it. The seals are just beautiful. They're so small, but the effort they have put into carving it is just worth just for that to look at it once. Okay. So the body of inscriptions looks sort of like this. So I want to ask you guys, does it look like writing? Just the left column, okay, the first column. So how many of you think it's random garbage that is just like some symbols of gods or something else? Writing in the sense that is a text that somebody's written, the whole inscription, not a single thing. So there has been many studies that show that it is writing mathematically. So of course, if you don't know it's writing, you can try to decipher it. If you can successfully decipher it, it is writing. If you get garbage, it's not writing. Simple as that. But you can mathematically also determine whether something is writing. Okay, so there are ways to understand or determine mathematically if something is a script, and one of them is something called the Gini coefficient, and the other is entropy. And Rajesh Rao et al. Have figured out or have shown that the entropy is that of script. And I think they were very conservative. I think they should have said a non-logographic script. And this study is by Ashraf and Sinha, and they have shown that regardless of the kind of script, the direction is right to left. So this kind of thing you wouldn't be able to do if it's not a script. So this is another kind of what's called internal evidence that so here you see external evidence that the text is floating up. That's kind of they're running out of space and they have to kind of squeeze it. That's generally indication it's a script. It's also right to left. And this is when something is on both two lines and one lines, and you can only read it from right to left. Okay, so now what is the language? And so to decipher something, you need to know the one thing you need to do is guess the language correctly. If you cannot guess, you can try one language, it fails, you can try another language, and you can try all 7,000 languages, and one of them should succeed. Okay. But it will take you a lot more time. If it's good if in the first one or two you guess it correctly. So there is another colleague of mine who his name is Steve Bonta, and he observed this particular pattern of inscriptions that many seals end in the jar sign, and the body of the text other than the jar sign is combined in many other inscriptions. So for example, in H278 you see those segments that also occur on their own, and there is like a jar sign. So his idea was that the jar sign represents some kind of suffix. So remember we talked about affixes and all that. So this is like either a accusative or a vocative or some kind of affix, and in the top the affix is only at the end. So to give a Sanskrit analogy, you can say Rama, Ramam is a affix, Chandra, Chandram, and you can say Ramachandram. You can say Ramam, Chandram, Vahanam, Ramachandra Vahanam. So you can smush those things together, you can do what's called samasa, okay, and you can keep attaching them like in what's called Tatpurusha Samasa. You can keep attaching them, and his idea was that particular kind of formation that you see a lot in the Indus inscriptions, like in H278 here, is evidence that this language is basically Sanskrit, basically classical Sanskrit. In Vedic Sanskrit also you get it, but not that much. And Steve Bonta is someone who has PhD in linguistics in both Dravidian and Indo-European. He tried for decades to decipher it as Dravidian, and then when he observed this, he realized the reason he couldn't do it is because he's using the wrong language. He switched the language and he got further ahead. His and my decipherments are different, but this idea I thought is a good analytical analysis of what language it could be. There are very few languages today that have this kind of morphology. There is Sanskrit and German that I know of. You don't find it in anywhere else. You don't find it in Dravidian, you don't find it in Japanese, you don't find it in Elamite or anywhere else. Okay, so this kind of narrows your language choices, at least your first language choice, pretty dramatically. So now that you have kind of have a guess for the first language you want to try, the question is, like what, are you going to try it as syllabic? Are you going to try it as what you're going to try it as? Okay, so it doesn't actually matter for regular expression, because if you're saying the first symbol is this and the next symbol is anything in that word that comes after this, if you get only ka, ga, cha, then it's abugida. If you get just the consonant, it's alphabetic. So when we look at the earliest phase of the Harappan period 3A, it only has 71 signs, and generally such a short number of signs typically indicates either abugida or maybe syllabic. Okay, so syllabic you can think 10 vowels into 7 consonants, or 10 consonants into 7 vowels, sort of is around 70. So the only issue with the list of signs is that this is a hand carved system. So you have people who have carved from different places, different times. They have carved the symbols. Every carving, every instance is different. It looks slightly different. There are similarities. So just like a handwriting, you may write A today in a slightly different way. Today afternoon it will look slightly different, and based on over time your handwriting will look different. So the question is, how do you determine what is actually the same sign and what's not sign? And if you kind of arrange them, you will see that it could be that these signs are evolving into more abstract forms, and they are also getting simplified. Okay. So instead of doing it visually, you can do it mathematically also. You can say, hey, so there are 2 items here. In the first item, you have the 2 things that look like a U, and you can try to see if they are the same by just doing the same thing. You try to find the matches in the dictionary. If there is a common match, then they are what are called allographs. Allographs are 2 signs or 2 shapes that have the same value. If there is no same value, like in the first one, you just they're distinct. Okay. So now that you have the method, now that you know that you can do it for InduScript, you can do it sign by sign. Okay. So although in my presentation, in my paper, I have shown it very neatly, one sign, then the second sign, the third sign, and the fourth sign. That is done so that the reader can follow, reproduce, and I also have it in programmatic form. They can run the program. It's easy to grasp and easy to accept. But I've also done it in various different combinations. If you remember seeing that, like you can do it with 4 signs in the beginning and then add 1 and then do 3 more. If you just want to solve it, you can do that as well. But this is neater. Also, you can just say sign number 4, then you can discuss it and so on. So here what I have done is I have I started with the jar sign. So I started in the reverse order of frequency. The most frequent sign is the highest chance of matching when you have few known signs, and you go in the reverse order. You maximize your chances of solving the sign. So the first sign is a jar sign, and once we got the jar sign, we use only the jar, find other inscriptions which have only jar signs and one other sign, and then try to solve it and so on. So we keep doing it one by one, and we get essentially all the values. And then if you just list them by the values, you can try to do what's called reconstruct the sign name, and that is as simple as looking up the dictionary for anything that starts with that letter which looks like this object. So for man, you look up what word you have for man that starts with a, and you find ayu, for example, and that's essentially the reconstructed name. The actual decipherment here is the first column and the last column. The center 3 columns are just the reconstructed sign names. If they are wrong, it doesn't change the decipherment. It doesn't change how you read it. And one of the things I figured out was that the names are so similar. So in this example, for example, for Vartri and Vati and Vatra, they are all so similar that it appears that the sign for that particular sound was communicated, and there was a someone heard it slightly differently, and that created a new sign. So the question is, so they have all this sign for all these values, and it's a very sophisticated civilization. Why did not they standardize it? And turns out they did standardize it, and it became Brahmi. So in these squares, if you look at the values, in each square the bottom left is Brahmi, the bottom right is Indus script. So you can see how similar they are. And many people have asked me which is Brahmi, which is Indus, because it's pretty much exactly the same. And remember, I didn't start with this. This is the result. I started it chain by chain like this, in a particular order, and the values were a result of the dictionary indicating to us this is the only value that fits this set of inscriptions. Okay, and you get this as a result. Okay, so here comes the question: how do you know what you've done is correct? So to solve the Indus script, it's the hardest problem. Is to solve it, and the harder problem than the hardest problem is to solve it in a way that people can follow, people can reproduce, people can understand the thing, and also prove that yours is the only one that is correct. So this is the hard part. Okay, now let's try to do that. So this is a little bit hard, but I think you guys will get it. So it looks like a very smart crowd. Okay, we even have some authors and stuff here, so it will be pretty useful. So the thing that you have to understand is that when someone says I have deciphered it, what they're saying is I have this information, I have this new information you did not have. Okay, and the question is, when people say I have this information, can that amount of information be measured? Can I put a metric on, say it is this much of information? Okay, and then we can try to see if the amount of message or the amount of information that person created is as much as in the key they created. Okay, so we'll go into that in a second. So information essentially is it means basically these three things at the top is that when something is certain, there is no information. Are we in IIC Delhi? Like if I say we are in IIC Delhi, you didn't get any new information, you already know it. I can say, today is this day of the week or whatever. If you already know it, if something is certain, it has zero information. There is also something called uncertainty. When the probability of everything is equal, then the uncertainty is maximum. So for example, let's say there is there's a very strong cricket team playing against a very weak cricket team, complete cracked cricket team. Almost certainly that the uncertainty is lower because you have that most likely the strong team will win. Okay, but when everybody is matched up, you don't know. Everybody is equal, you don't know. So that is one of the properties of measuring information. And the last is you should be able to take multiple information and add it up. And the notation for this that works has all these properties minus log probability of that event. Now that is information, and there's something called entropy. Entropy means is what's called the expectation value of that information. Now what's expectation value? So if I have a coin, I have 0 written on one side, I have 1 written on the other side. If I toss it, okay, many times, what's the average value? Anyone? Half. Okay, and if I toss it millions of times, you can be very confident it's half or very, very, very close to half. Okay, that's called the expected value. It's probability into the value. The same thing for dice, it's 3.5, and you can generalize this as what you see that sigma pi log pi. That's essentially what it is. It's just a mathematical way to write what I just described. So The uncertainty example, we're talking about equal uncertainty. The first one shows a fair coin. It lands heads 50% of the time, tail 50% of the time. If it lands 3 out of 4, it lands one way versus the other, it is actually less. The entropy, the information in that is less, okay, because you already in advance know that something is more likely. Okay, these are just some terms, so that when I speak about it, I can use the technical terms and you guys don't panic or you guys don't start hunting for your phones or whatever, okay. So, if you can read something in a text that is known to you, it is called plain text. It's plain means you can see it, it's plain, that's simple as that, plain text. Cipher text means you can't read it, you don't know the values. Cipher means hidden, so that's all it means, very simple. The alphabet or binary of cipher text or plain text is called plain text binary or cipher text binary. Okay, now we talk about the key. The key is the assignment of values to a symbol. So, when someone says I have deciphered the index script, says okay, what are the values? Well, for jar sign means is this, the man sign means something else. So, that list of assignments is called the key. The full list is called the key. The number of ways you can assign those values is called the key space. So, key space is the number of keys. So, you understand the difference between key and key space. Key is what you have assigned. Key space is using that paradigm, how many different ways can I assign, okay. You will get it in a second. So, for example, I have a lock, I have a digital lock, it has numbers 0 to 9, I have to press one button to open the lock. How many different buttons can I open? 10, because 0 also is there. So, the key is whatever was assigned, like if it is 5, that is the key. Key space is 10 different values, okay. Now, if there are 2 digits, I have to press twice, I have to press one number and another number. Now, how many are there? 100 is correct, because 0 0 0 1 0 all the way to, and if it is of length n, 10 to the power n, that is it, everybody is correct here. So, if you change that to alphabet instead of number, it just becomes like 26, right. And if it is of unknown length, like if you put variable as p and c, you get something like that. It is just raising to the power, that is it. So, if I just start this talk with p to the power c, a lot of people will say what the hell is he talking about, what the hell is p, what is c. So, that is why I have to kind of give that example and say this is all it means there are so many possible keys, okay. Now, let us understand a little bit about bits and like how to measure information, okay. So, if I ask how many of you are you over 18, what are the possible answers to this, yes or no? Now, of course, some people are very sophisticated, they will say of course, definitely, bigger words, right. But the actual information there is just yes or no, is one bit, there are 2 alternatives. The 2 alternatives you can write as 2, which expressed in powers of 2 is 2 to the power 1, so it is 1 bit. Now, if I say what is the day of the week today, there is 7 answers, close to 8. So, it is slightly less than 2 to the power 3, 2 to the power 3 is 8, right, 2 into 2 into 2. So, it is 3 bits. So, same thing now if I write mathematically, if there are n possible values, the amount of information there is log to the base to n. So, log just means when you raise it to that power, what is the power you are raising to, that is just log, that is all it is. So, if I have a alphabet which has p symbols, it can produce log p bits of information, log to the base p, okay. So, we saw all of this, just I know when the moment I said people see variables, they are like what happened, but you have already understood it, okay. Essentially you produced some information, you produce symbols, okay. So, you have symbols, you arrange them and you can produce certain rate of information, and but most of those symbols do not carry information, like you remember you saw the CAT, CAF and so on, most of them do not carry information, most of those combinations. The part that does not carry information is called redundancy, okay. So, there is information content and redundant content in the symbols of a written inscription, So this is just derivation, like you can, max compression is the information divided by the symbols, and if you subtract that, it's called redundancy, and at the last we just calculate the rate of symbol production in terms of the rate of the language redundancy. So it's okay if you don't understand this, it's okay. Now here comes come back to the question, how do you know that what you wrote, what you deciphered is correct and what everybody else deciphered is wrong? So there is a principle of information theory that says that uncertainty, remember we talked about uncertainty? Uncertainty is the amount of choices you have when deciphering something, okay. So when somebody has a symbol, the amount of different choices we can make about what that means is uncertainty, okay. So that can only come from the key basically. So you remember when people are assigning values, jar sign equal to this, man sign equal to this, that assignment is the only way to add that uncertainty, makes sense, because the inscriptions are the inscriptions. So you have only two things to read a decipherment, you have inscriptions, you have the key. Inscriptions, you are not changing it, that is 4000 years old. The key is what the decipherer has the flexibility to change. So that is where you can add uncertainty, you can control what the meaning is, make sense. Okay, so this I am not going to go through this in detail, but basically the summary of this is that once you read past a certain amount of characters, okay, depending on your key, then there is only one possible decipherment. That point is called the unicity distance. So mathematically, given a decipherment, you can calculate its unicity distance and see if the decipherment has read beyond that. If it has read beyond that, it is reliable. If it has not read beyond that, it is dubious, okay. This is a very nice experiment. So this is the Indus symbol. What this means is, just by looking at something, if you say I have looked at this, I have stared at it, and in my mind I know that it is this value, that is not a method, that is just an assumption or a guess or a feeling that has no basis in reality unless you are Mahadevan and some goddess is telling you. And this is a method used by some famous decipherers. So you have to understand these guys, the top three are from Parpola, the bottom are from Mahadevan, highly respected figures. They have done a lot of great work in the Indus script, so I am not, I respect them in everything else, I am just disagreeing with their decipherment, okay. So for example, Parpola said that the intersecting circle is bangles, and he had these three things, he said it is a hearth, and when they are together, hearth bangles does not make sense, so he claimed it is pregnancy bangles. Now what is happening here is that when they are in a particular order, he has to add more to the key. Did you see that? So he is generating the key as he is reading the inscriptions. So is he reading the inscription or is he reading the key? He is reading the key, right? So that is what essentially is the issue with this kind of logographic things, okay. So same thing with but even that won't save you, because when Mahadevan assigned these values, ruler, jar bearer and chicken, it turns out there is another inscription that you would have to read it as ruler, chicken, jar bearer. And I don't know if any nice restaurant in Khan Market has this kind of dish, but it doesn't, it's not something that's meaningful. And this is typically what a lot of the decipherments look like. This is not mine, this is some unknown decipherer. It's probably not very clear, but essentially when they read, you see a lot of these parentheses, those just not written. So Sri Ra Cha, for the first line he is assigned Sri Ra and Cha, he is reading as Sri Ramachandra. So what does that mean? It means there is no list of valid and invalid words. If you can just insert things, if you can just read something as the other, that is essentially you are saying there are zero invalid words, everything is valid. I just have to pretend that it says something else. Okay, so here we come to what's called unicity distance. So we talked about unicity distance. In a logographic decipherment, the number of values is unbounded. So this symbol, what prevents you from assigning any value to it? I mean, you may have some personal internal consistency that wants you to imagine that it looks like something. It looks like wheels or something round, but nothing prevents you from assigning any value to it, mathematically speaking. I could call this a dog, I could call this a car, I could call this a baby, I could call this an airplane, I could call this an air balloon, anything, right? That it's what's called unbounded in mathematics. There's no upper bound, okay? And if you have this other situation where you can just make up any word that is not complying with any grammar, syntax, or anything of any language, if you're just making it up, then the number of values you have, invalid values you have is 0. So every word is valid. So that means that no matter how much you read, it's a dubious decipherment. Makes sense? So here we show it in the last line as, we can show it as limit because only because infinity actually means specifically something in mathematics, but you can think of it as infinity by anything is infinity and anything by 0 is infinity, okay? So any decipherment where the number of possible values, not the number of values you have assigned, but the number of values you can assign in your scheme is unbounded, or the number of words that you can read is unbounded, that is not dubious because the unitary distance is infinity according to information theory. This is a general for things that are not logographic, things that are syllabic or abugida or anything else. This is the formula. It comes to number of signs divided by 0.7. 0.7 is we saw the redundancy of languages. C is the number of signs you can read differently. So if it's the same, so for example, if they're just in a particular order, they don't add equivocation, you don't count them. So for me it comes to around 471. And how much have I read? I've read about 5,134, which is, I would say it has cleared that pretty decently, okay. So mine is the only one I know that has crossed the unitary distance and is the only reliable decipherment. Okay, so these are just different supporting studies that are done by others. Now a couple of questions that have actually been asked, I will just proactively answer them before we go to open the field. So again, this is a technical question. So does unitary distance work for one huge inscription or does it work for many small inscriptions? The answer is yes, and this quote is from Shannon's paper, which analyzes this information theory stuff, and essentially it's because a cryptogram is a transformer. It's not just a rendering of a particular message. It is, you can think of it like a telegram. Anything that comes here gets transformed and sends out. No matter how much you send it, it's the same cryptogram. This is one of the other things that you're saying it's abugida. There are all these symbols that look alike. It has the same value. It has the same sound value for all the symbols. It's very, very normal in old scripts. Mayan script is actually not that old, but it has, for example, all these are same different symbols for the sound oo. Okay, that's also very normal. And yeah, so during the decipherment, I've used some words from newer literature like Itihasa and not just the Vedas. And they said, can you do it using only the oldest words? Yeah, but I wouldn't be able to present it like that nice linear format. I would have these clusters where I get 4 in a bunch, then I get 1, then I get 3, and so on. So, but it would result in the same value. Nothing would change. Okay, this is the other is, have you used Panini grammar? Can you use any other grammar? Actually, there are a couple of Panini grammar covers about 80 to 90% of Vedic grammar. It leaves out certain elements. A couple of are also present in the Indus inscriptions. There is this website indusscript.net where all the inscriptions are deciphered or translated. You can look at it. You can search for some famous things. You can search, for example, Pashupati seal. It will find it. Okay, Dholavira, you will find it. And we have deciphered about 38% of the inscriptions. We have deciphered all inscriptions 6 or longer. The short inscriptions will also be deciphered in next to 3 to 6 months. Okay, so we are expecting the entire corpus will be deciphered sometime in 2025. So yeah, any questions here? Go ahead.
My question is actually sort of linked to what happened later. How are you going to give this a certain legitimacy where it cannot be questioned? I'm not a mathematician, I'm zero there.
Right.
How are you going to give that legitimacy? Secondly, because there are other interpretations,
Yeah.
nothing has been actually technically counted as such. It has not got the legitimacy in the public domain. We really don't have anything. Who does that? Who is going to authorize that? And when do you think that can happen? Like
Okay. Yeah,
international?
no, that's a good question. So the acceptance of decipherments of scripts always take very long time. So the Egyptian hieroglyphs were deciphered by Champollion, and it was not accepted till he died. Okay, the linear B took a few decades, for not few decades, but it took a decade or so before it was accepted. And this is because when something is deciphered, the number of people who want to jump in and say this is correct, even though they accept it, they are very cautious, because let us say they endorse it and 6 months down the line someone disproves it, they now have to retract their endorsement. So it's very slow, it's just diffusion, and it has to kind of so this is how it happens. However, the zodiac cipher was accepted immediately because it had crossed the unicity distance. Okay, so mathematically what this means is, so I understand not everyone here has that kind of background in math, but in information theory, if you cross the unicity distance, it means that you have solved it beyond all doubt. Mathematically, it's impossible for it to be anything else. Okay, so it is simply like this: there's information here, and you make some transforms, and information comes out here. You cannot generate more information than it went out or was in the transformer. You cannot generate new information, even God cannot do that. Okay, so unicity distance is a very strong metric, and the only question would be is if I have made a mathematical error or some procedural error. But the modeling of the problem, the application of the problem, and generating this is an old well-known mathematical system in use for hundreds of years. So this is nothing here is my invention except modeling the problem correctly. Mary Queen of Scots in the medieval times or in the Victorian times, her cipher was broken in the same manner, same technology. Michael Ventris' decipherment of linear B was redeciphered using this method. Okay, so it is not that this guy's done something, is it right or not? This is well known, well understood, broadly well understood, like very broadly. People who are in this field, they know about it completely. Okay, and so we will see. I have presented to all the IITs, IIScs. There's been very good response, and there are people in IITs who are writing supplementary papers based on this. So we will see how it goes.
If we have the key, why can't we get instantaneously translations of all the inscriptions?
So we can, and I'll show you what happens. So L5 means show me everything length 5 or smaller. So what happens is, see, this is all auto generated. See the one with the star, that's auto generated through the key, and some of them you can kind of read, and but what happens is it's a Bronze Age script. So when there are sandhi or something like that, you have to kind of figure out what it is. So for example, if there is a string leader got in, you can read it as leader got in, or led ergo tin, or leader go tin, something like that. Okay, so that particular there's no spacing, and some of these issues are there, because you can, it's one thing to read it, another thing to read it consistently and meaningfully. So for example, there's a sequence that is, I read as varam, okay, but it can be read as vrana or varna also. Okay, it's only in that context. It's just like it's true even in modern languages, like lead, led, minute, all of those things exist. Okay, so because of that, although we auto generate most of it, someone has to polish it a little bit. Yes, please.
The researches of Professor B.V. Lal in his The Rigvedic People, Invaders, Immigrants, or Indigenous,
Yes.
and also his Hindi translation, Aryukadi Desh Bharat, and furthered by Dr. R.S. Best and his research, which claims that the Rigvedic people and the Indus Valley people are one and the same, not just novella. Does your script and the decipherment that you have done, does it indicate the same or is it different? Because if it is the same, then it is beyond migration, invasion, transmigration, anything. It is one and the same.
Right. I mean, you can look at the inscriptions. They are of a religious nature, and they are essentially mostly about Rudra and Vedic gods, and a couple of Puranic incidents. So based on that, based on the iconography and so on, it's pretty apparent that Indus people were also Vedic people, or Vedic culture. I don't know if it's during Rigveda or Yajurveda, because most of these seem to be to do with the yajnas. So I think it could be closer to Yajurveda rather than, like, the mature period could be to do with Yajurveda rather than Rigveda. Yes, please.
And so, sorry, just one small question. Is there any mention of Ram in your decipherment?
So far, I've only seen something that says the killer of the one with 10 heads. Killer of the 10-faced one. Here it is. So for example, this one H776. That's reads as Dashanahan. Dashanahan means the killer of one with 10 faces. You could interpret this as Ram, but just based on one, I wouldn't. I would like to have 2 or 3 to have a more confident answer to that.
According to Dr. Bisht, there is no mention of Ram in the Rigvedic text. So, can we still claim it to be similar?
So that is beyond my, out of syllabus for me. Okay, so that is something that other people have to research. See, my job is to give the values, and just even this translation other people should do, but I'm doing it because I'm just trying to contribute a little bit. But I'm sure other experts will jump in and answer those questions. You can join our Discord.
Yeah, so I was actually going to comment on his question. And, I have read your paper, and you mentioned that the earliest inscriptions were 4000 BC. And so you have found that it's in Sanskrit. So I think that immediately takes care of the Aryan invasion or migration theory, because they say that these guys from the steppes, they came between 1900 and 1500 BC, and then they came and taught everyone here Sanskrit, and they composed the Veds also. So if people were writing and speaking Sanskrit in 4000 BC, that immediately shows that that theory is wrong, and we don't even have to go into any other arguments to show that that theory is wrong. So that was just a comment. It's
Right,
not
that's a comment. The only thing I would change is 4000 is the earliest graffiti, not the inscription. But okay, let's give it to the Mr. Archaeologist Neha. Neha, go ahead.
I wanted to ask, so when you were going through inscriptions, could you see evolution of script,
Yes.
like evolving Harappan? And you've shown some similarity between Harappan script and Brahmi.
Yes.
So, can you see the Harappan script evolving
Yes,
into
yes.
Brahmi, or do you think we are missing that transition phase from Harappan to early Brahmi?
No, we do. It's in my paper. There's a list of mixed Indus Brahmi inscriptions where some letters are Brahmi, some letters are Indus, and so on. Okay, and you see over time the Indus characters get fewer and fewer, and the Brahmi characters get more and more. The best example of that is in Kiladi in Tamil Nadu. The earliest stages have only Indus inscriptions, then you have a big mix of both, and then on top you have only Brahmi. Okay.
Yeah, so there was one interesting part of the slide for me, which was Markov trees essentially.
Yes.
So, is it fair to say that every language has a unique Markov tree? So,
By definition, yes. By definition, it does.
so yeah, I would like maybe I should go through the slide again later, but
Yeah.
like basically how does it how does a Markov tree help you in decipherment? Is it like if we create a Markov tree of the inscriptions and then we map the keys from the original language to the decipherment, so they will be similar.
So yeah. So essentially, when I said I did regular expression, regular expression is essentially something called finite automata, and finite automata essentially transitions on a graph of different words. So Markov tree essentially is the tree with probabilities. Okay. So eventually, because the regular expressions goes on the tree, the Markov tree is mostly, I just keep that for conceptual anchoring of the residue class, which is one of the parts of the Markov tree. Mike is on.
What is the use of the seals?
Right. So the seals seem to have at least the messages seem to be of slogans, religious in nature, and they could be mottos of the state or some organizations, similar to today people use Satyameva Jayate, which is from Chandogya Upanishad. In the Navy uses Shamno Varna, which is from the Rig Veda. Okay, so organizations using these mottos is also continues into Gupta age. It continues to today, and it continues even to like Indonesia and all. It is very common to use in Indian context to use religious mottos for the state, for your organization, even for products. Like like you have Ganesh BD, right? So what is Ganesh got to do with BD? But they put that because they believe that it could be that when you send goods over the sea, it will protect the goods or whatever. So some of this is just I'm imagining because that is beyond, like it goes into archaeology and all this other stuff that is beyond my scope of my work.
So they were stamped into object.
They were stamped onto the pots that carried it and so on, and some of them are just seals that seem to be standalone, like they're not even on pots.
Just a small question. So I think the main part of the slide related to decipherment was residue classes and how you
Yes.
try to decipher it. So if you could, tell us a source or something from,
It's a Shannon's 1948 paper, 45 paper. 48 paper doesn't have cryptograms, it has the communication. In 45 paper, there's everything. So remember, in those days, World War II, the standard for communicating secret messages was cryptogram, and he was analyzing how cryptograms can be broken, and if you break it, how do you know that you have the correct answer? Same question we are doing for InterScript. If you have broken it, how do you know it's the correct decipherment? Okay, so that's the analysis, that's where all this comes from. Okay.
The corpus of Indus science, it spans around 2000 years.
The signs originate in 4000 BC, but most of the inscriptions are between 2600 and 1900 BC.
So
You can say 2000, yeah, from 3000 to 2000 BC.
So, can you arrange your decipherments in a chronological manner and also find out whether there is some kind of linguistic evolution of the same word over 1 millennium or two?
That is something that can be done by people who want to build on this project. So this database is publicly available, and so first of all, we don't have the dating for all the inscriptions, because when they first dug Mohenjo-daro, it was destructive. They just dug the whole thing up. So the biggest site with the most inscriptions, we don't have the dates. But in later sites like Lothal and all, we have some dates, but we don't have that many inscriptions. So that may be kind of hard to give an exact answer, right? But perhaps with the help of ASI and all, maybe that's a project that if someone funds that, it's not a simple project. It's a data collection, and someone has to fund that project.
Sir, you said that the written script only have to match with one single language. Like there are 700 languages, and you have to find the correct language, and then it will match.
Right.
And then you said that the Vedic language, Vedic Sanskrit, is matched with that, and the unicity level is 38%. Is it possible? It's way above the general.
So in the script, you can write multiple languages, and the Middle Eastern, the Mesopotamian scripts, the inscriptions are written in Akkadian and Sumerian also. Okay, but when you decipher, if you only take one language, the flow is simpler, the proof is simpler. So if anything is not, so I have picked only one language for the decipherment, the inscriptions matching that thing, okay, which match in the dictionary.
Is it possible? Is there any predecessor of the Sanskrit, or else we can categorically say that the Vedic Sanskrit is the original one? There is no predecessor of it.
Previous version of Sanskrit, I have not found an indication. I have only found a couple of Vedic forms. One is a subjunctive, the other is I think it's infinitive. Those are the conjugations, but pretty much you have to understand 95% of what you call classical Sanskrit is really Vedic Sanskrit. It's essentially the same.
Just wanted to find out whether the scripts change from the location. For example, from Gujarat onwards towards Pakistan, where the Harappan thing, and then to Rakhigarhi, where they have. So you've seen some evolution. Changes.
So by the time the mature Harappan phase started, there's so much travel inside that the same inscription you see in different location and you see across different times. 100, 200 years apart, you see the same inscription. In fact, there's one inscription that is all the way into Kaushambi, which is between 100 BC to 100 CE. So it's like when people travel around, like you find some passports, Indian passports, you can't tell which is where because everybody is moving around. So it was a very dynamic culture, civilization.
And have you found any evidence of mathematics in some of these scripts?
Not in the inscriptions, but I found that they have understanding of the method to create determine the cardinal directions. They have knowledge of fractals and so on. So it's in the different artifacts, but in the inscriptions themselves I have not found. Yes.
The Britishers have tried very hard to establish that Indian civilization is not the oldest. But the later research excavation work in reference to Professor Grover, Suraj Prakash Gupta, Devensuru ji, and Dr. Grover. The fact the new theory has developed, the Indian civilization is the oldest, and most of the things flowed from there. What do you think about that? What is your knowledge?
I think there is.
What is the period of the Indian civilization?
So we have the earliest settlement in 7000 BC or something in Birana, and there is no reason to assume that the earliest what we call civilization is anything. So it all depends on how broadly you define civilization. If you mean a bunch of people living together and doing farming as civilization, then 7000 BC works pretty well. If you mean actual houses, streets, urbanism, trade, all of that, then it has to be a bit later, but not a lot later, because we know, for example, by 5000 BC, the Indus Valley was exporting cotton to Israel. Around 6000 BC, we some Indian motifs in the pots that were exported to Mesopotamia. So it all depends on, when you say urban or civilization, it depends on definition.
The earliest period of the Indian civilization.
That's what I'm saying. It depends on how you define civilization. But I would say from 7000 BC.
What is the fact, the earliest period of the Indian civilization?
If you're very broad, then you can say 7000 BC. Yeah. If you just say domestication of plants, then you can say 9000 BC when rice was cultivated in Gangetic Plains. So it depends on how broad your definition is.